Come here, Bryce. Let me see your way. Did you rearrange it to flip intercept forms?
Yeah,
okay, so you can...
side though.
Oh, yeah. So for x equals 5, those are your right to put this here, but then we draw the line this way.
Oh.
On this one, you do y equals -1. You had them backwards. And then you draw it that way. Okay?
How do I do this one? Isn't it?
Yep.
What is the -1? You put that here?
Yeah, so I'm going to go... Then you go down.
-4
over 3. Good job. Yeah, I'm going to go through that type next. 1 second, I have to take attendance a minute. Just 1 second, I have to take attendance. And I will answer your question. Here. You can't be on there during class. It's too much of a distraction. You have a class meeting today in the auditorium.
Miss Conway.
Yep.
Did you say we had that class meeting?
Sophomores have a class meeting.
We just had one yesterday.
Sophomores.
Oh, it's sophomore.
Okay, here we go. Let's get fast at it. We put 0 in for x. Goes away. You divide both sides by -5. What's -15 divided by -5?
Oh, no.
Positive 3.
Positive 3. We graph 0, 3. I'm just finding 2 points on the graph. I'm finding 2 easy points, the x-intercept and y-intercept. Put 0 in for y. That goes away. Now what am I going to divide by? 7. So I do -15 divided by 7, and it's not exact. I get -2.1. So I put about a little past -2, I connect my lines. I divided by 7, yes, Landon, to get that. That one drew over there, Sal. Okay, let's quickly review horizontal and vertical lines. Y equals -1, that tells you the y-intercept. So go ahead and put -1 on the y-axis, and I draw a horizontal line through that. Those are as easy as that. Let's go on the back page. Can you find the one with the x equals? Tell me what number that is. Number 5. It's 5. So x equals 5. I go to x equals 5. Santos is going like this, up and down, vertical. Good.
But you can't.
So when you just see an x equals, those are vertical lines. When you just see a y equals, those are horizontal
But
lines.
what up the BLT is not a
It is not a function. You're right, Shane. That line is not a function. Good memory.
wrong unit. Okay.
Okay, now, I find that these last 3 are easier. These are y equals mx plus b. Wait a second. What's that? What's that called? Slope-intercept form. Let's do 7 because it's the harder one, okay? So, this is your y-intercept. Be careful you don't mix those up. So, would you go ahead and put that on the y-axis? Don't put it on the x-axis, put it on the y-axis. Then you're going to use your slope and do rise over run. What am I going to do then? What does negative 4/3 mean? Bryce, tell me. Down 4 over 3. 1, 2, 3, 4. Down 4 over 1, 2, 3. How do you do them if they're not fraction slopes? Just make it over 1. Would you do 6 and 8 for me a minute?
It was already there.
All right. Start at -1, up 1, 2 over 1. Does your line look like this? For question 6. Just do a check. This one you start at 2. What did you do next? Michaela's saying down 6. 1, 2, 3, 4, 5, 6 over 1.
What the fourth?
Say again?
Down the fourth? 4-1, negative 4-1?
This one?
Yeah.
No, I went down 6 over 1.
Yeah, thank you.
Oh, is that the ordered pair? Yeah, it is. It is. Sorry, I didn't know what you were asking. All right, you guys. Now, why are we doing this? Well, today we are going to solve a system. Now that we know what lines are, hopefully you know what a line is. Sean said, or Sean, why did I do that? I did that before. Shane, you're not Sean. I know that. Shane said, hey, y equals mx plus b. Yeah, that's the equation for a line. He's right. Would you turn to this page? So what is a system? Well, a system of equations is just 2 or more lines. Now, in this class, so we're going to have 2 or more equations. In this class, we're going to look at lines. I might show you some things that aren't lines, but only just to show you they exist, not because for our class that we're going to study them. When you get to pre-calculus, if any of you ever get to pre-calculus, we actually do 3. We'll do 3 lines or more. But for us, we're going to just do 2 or more equations.
What do
Santos?
people do?
I don't have time for that, Santos. All right, solution of a system. Solution of a system. Okay, an ordered pair. So it's going to be an x, y. It has to work in both equations. It's got to work in both. Okay, so let's do a couple of these together. You might want a calculator out to do this. You got one? And I want to see a little bit of work, meaning what did you plug in? Let's check. We have all these are systems. Do you see them all? Okay. Bless you. What we're going to check is the ordered pair, and the ordered pair I'm giving you is negative 2, 4, a solution to none, one, or both of the equations. Let's check. So how do I do that? You plug it in and see if it makes it true. What are we going to put negative 2 in for? What variable? X. And 4 is going to go in for y. Let's take this top one. You got to do both of them. Y equals 4x minus 2. So I'm going to write, what was my y? 4 equals 4 times x, so 4 times, what am I going to put in for x? Negative 2 minus 2. I need you to check for me, does 4 equal 4 times negative 2 minus 2? What's 4 times negative 2? Negative 8. Negative 8 minus 2 is negative 10.
No.
Does 4 equal negative 10?
No.
No.
4.
I'm going to put an X there. So it did not work in the top one. Let's check the second one. I'll get a different color. Maybe my pink. Let's check the second one. 2 times x plus y equals 0. So I'm going to do 2 times negative 2 plus 4. Does that equal 0?
Yes.
Yes. Negative 4 plus 4 equals 0.
7.
I'm going to put a star. So how many did it work in? None, 1, or 2? 1. Does that mean it's a solution to the system?
No.
No, because to be the solution to the system, it's got to work in both. Yeah, it's got to work in both. Okay. Let's try another one. You guys want to try it on your own?
No.
You're
no,
not
no.
ready yet?
One problem.
Oh, okay, we'll do another one together. I don't know, maybe you got it already. Let's do this one. Same ordered pair. Same ordered pair.
-3.
So I'm going to do, this is, y is 4. Does 4 equal -3 times -2 minus 2? Yeah, -3 times -2 is 6. 6 minus 2 is 4. Works in the top.
You guys don't math that quick.
Well, then if you're not good at that mental math, then you got to get your calculator out and follow with us, okay? Let's put it in the bottom. X plus y. So what am I going to write?
-2.
-2 plus 4 equals -1. Is that true?
No.
No. X.
And-
I know I changed I did star before, but X, not true. Worked in 1, just like the last one. Is it a solution to the system? No, not a solution to the system. Gosh.
That's the second power.
Ooh, what do we do if it's x to the y equals x to the second power?
That's-
Just square it. Bam. All right, y equals x squared. Does 4 equal, be careful, -2 squared? -2 squared means -2 times -2. That's, that's true. -2 times -2 and negative times negative is positive. Y equals 1/2 x plus 5. So does 4 equal 1/2 times -2 plus 5? Okay, somebody do it for me. What's 1/2 times -2? -1 plus 5. Is that true?
Yeah.
Yay! What does that mean?
Oh, that's a solution?
Yeah, it worked in both. This is, because it worked in both, this is a solution to the system. Do I need to keep going, or do you guys have the idea there?
Let me say SOS. Solution to the system.
SOS, I'm going to think you're making a call for help.
Can we do STS?
If you tell me SOS, I'm going to be like, Santos needs help.
Can we do STS?
You can do SOL to system.
SOS.
That's what you could abbreviate. Okay, we got it. Now, I think you got it. I don't want to do extra examples. I would rather give you some time to practice it. The second thing that we're going to do is we are going to solve by graphing. Here's the deal. Solve by graphing just means we're going to graph both lines and we're going to see where they meet. That's it. That's why I said you needed to know how to graph. Let's do it. They're both slope-intercept form. Santos, tell me what to do first on this one. Y equals 2x plus 1. What should I do first?
Plug in 0. Right?
Well, you can, but I would, if they're in slope-intercept form, I think it's easier to do the rise over run business. So what's the y-intercept?
The Y?
Uh-oh. Jarrell?
For the first one, y equals 2x plus 1, the y-intercept is 1.
The y-intercept is 1. Okay. The slope is 2. So, Corey, what should I do if the slope is 2? What do you think? Rise over run. Take a guess. Michaela? Go up 2 and then over 1. Here's what I will tell you about these, because sometimes it's hard to tell where the lines meet. You can keep going up 2 over 1 if you want to get more points. You don't have to, but it might help in the long run. Would you draw your line? Okay, I'm halfway done. Aubrey, in the second one, this one down here, what's the y-intercept? negative 4, would you put negative 4 on the y-axis? We can. And then we'll just make sure when we draw our line, Shane, though, that we extend, that's why we got our straight edge. Shane, you said I can't go down because you know the slope's negative, so what are you supposed to do? Down 3, 1, 2, 3, be accurate, over 1. If you want to reverse it and like go back this way, you can.
Yeah, I did that.
Cool. This is why I wanted to do this. What does that look like to you? What ordered pair? Negative 1. To me, it looks like negative 1, negative 1. This is, so I'm negative 1, negative 1 would be the solution. So on a graph, what's the solution then? Where the lines intersect. Who can see a little bit of a problem with graphing to find solutions? Who could tell me maybe what's a little bit of, could be a problem if I want to solve and by graphing solutions? Aiden? Yeah, we'll talk about that in a second. If they're parallel, or was it super easy to tell negative 1, 1 because we're graphing the lines ourselves and we might make some error on our straight edge? Yeah. So solving solutions by graphing is not always the most accurate. Mostly, I need you to be able to look at graphs and know if there's a solution or not. And how do you tell is if they touch. Okay. Next one. Solve by graphing. Okay.
There ain't no line.
There isn't, but Shane, let's do, this is in standard form, so let's do our intercepts.
Oh.
Okay? Let's do our intercepts. All right, so I'm going to put 0 in for x. Put 0 in for x. You guys tell me I covered it up. What should I divide by? 4. What do you get?
3.
Okay. Now I'm going to put 0 in for y. I'm going to cover it up. What should I divide by 3? It would be
4.
4. Would you graph 0, 3 and 4, 0?
I don't know how to do the fractions.
Okay. When you have the fraction ones, you don't go over 1. You go over by the denominator of 4. All right. So for the second line, somebody tell me where I should start my line.
3.
3 where?
On the y.
3 on the y-axis. Oh, interesting. It's the same point. Then, now what? Down 3. 1, 2, 3. Oh, what?
It's the same.
It's the same stinking thing.
Oh, that's crazy.
Okay, so it is a double line. I like that. Double line. Okay, so how many places does the line intersect?
None.
Twice?
Not twice. It doesn't intersect at every single little point on the line.
Yeah.
Yes. Okay, so when they're the same line, there's a word for that. Have you heard of the word coincidence? Okay.
I'm not spelling.
Those are called coincident lines because they're the coinciding lines. When there's the same line, that means that all of the solutions go forever and ever and ever. There's a word for that. What's
Oh.
forever and ever.
Infinity.
To infinity and beyond. So this
It was like me.
is infinite solutions. There is an infinite number of solutions. So when you get the same line, every point on the line would be on the other line. Oh, I'm sorry I'm boring you. All right, last kind. Last kind.
Is this the last thing we're doing?
Yeah.
Okay.
Well, we might summarize.
No, you can go
No,
backward.
no, we're gonna summarize what happens, but. Okay, how about this one? Put 0 in for x.
Yeah. Oh, that's -4. Huh.
Okay, divide both sides by -4. What do you got?
2.
Careful.
-2.
What?
Negative.
What?
Where? Oh, wait, wrong numbers.
Ooh.
-2.
So 0, -2. All right, now I'm going to put 0 in for y. Cover up the y. What should I divide by this time?
2.
2. I get a
4.
4. Let's graph that line.
Oh, I'm cooking.
Okay.
Doesn't matter which way you go over.
What do you mean? Oh,
Never mind, it does, because one's negative and one's plus.
yeah. Alrighty. Tate, where should I start that second line?
+2.
At +2? Yep. Good job. Autumn, what should I do now?
Go up 2 and
Autumn, what should I do now? Up 2 over 1? Rise over run? There you go.
This is easy.
Up 1 over 2 from this point. Up 1 over 2. Weird. What's going on with this one?
I'm correct. I bet you're wrong.
this cover.
Wait, what's going on, Aiden? What's going on with this? I'm picking on you because you said something about this earlier. The lines are parallel. What does parallel lines mean? They're never going to meet.
They're paralyzed.
So where's the solution to parallel lines? There is none. Okay, so
Can you say the paralyzed?
no, that's not what that means. That doesn't even mean the same thing.
Parallel.
Parallel lines. When you see parallel lines, you're going to say no solution.
No. S-O-E. So,
Side back to the
Salad.
Okay. So, Shane, the last thing is a summary, and we're not doing the whole thing. Just relax. Okay. But it's a summary to help you as you're doing your assignment today. So, what do parallel lines look like?
Straight.
All lines are straight.
Doesn't say.
Be more
No, that's
specific.
true.
That's true.
Nobody's remember graphs. Some graphs go like this.
That's a graph, but a line is straight.
Ooh,
Santos, ooh, ooh, ooh.
like 2 lines and they're the same thing.
2 lines that never
Meet.
meet. So
Yeah.
today when you graph and you get parallel lines, how many solutions are there to that?
0.
No
No
solutions.
Wait, isn't there a symbol that we do?
The circle with the slash. Intersecting lines. Would you just draw any 2 lines? Would you make sure they meet? Would you circle where they meet? How many times do intersecting lines meet? Once. There is 1 solution. Now, it's going to be an ordered pair though. So make sure you realize it's going to be an XY.
Constant lines. And that means
Remember
like the
coincident
same
lines? Coincidence. It means the same line. So this is kind of hard to draw would you draw a line, and then would you draw a line right on top of that line? I would do 2 different arrows in 2 different spots, so you know it's the same line. How many solutions to that? Infinite. Infinite solutions. We will talk about these 2 things later.
Could you use the figure 8 if you're doing it instead of words?
I'm okay with that. I'll allow it.
So now we're done?
Okay, would you, for the rest of your time, work on page 3? Page 3. I will walk around and help. It's if you don't finish.
I'm too tired for this.
I'm too tired for you. Do your work.
It's too cold out.